what is your written as?
Yeah, okay. Yeah, I'm sorry, that kind of squished. Let me write it over here. It looks like this. The nth root of b, thank you for asking. Okay, so if a to the n equals b, then, and n is a positive real number, so 1, 2, 3, 4, and so on, a is called the nth root of b. So like if there's no number, it's a square root. So let's just do a few to kind of get the hang of this. So if I have 5 to the cube is 125, then the cube root of 125 is 5, like that. If you have 3 to the 4th is 81, we would say the 4th root of 81 is 3. And if I have negative 6 in a parenthesis cubed is negative 216, then the cube root of negative 216 is negative 6. Now, example 4 says, can you take an even power of a negative number and get a negative answer? So an even power means to the second power to the fourth power. All right, George, can you explain why? You're absolutely right.
Well, because a negative times a negative is a positive, so I mean, it only works for all.
Exactly. Good explanation. So look, a negative times a negative is positive. It's not possible to get a negative times a negative to give me a negative. So here's a note. You can't take an even root of a negative number. That's take, okay? So no, you can't take an even root of a negative number because, exactly as how George described it, a negative times a negative is positive, okay? Sometimes we abbreviate it when we see it, NRR, no real root. So if you ever see NRR, it stands for no real root. So case 1, if n is odd and a is positive or negative, then there is one real root. And I'd like you to circle this piece. If n is odd, and n is the root or the index. So we use the word root and index the same way. So what is the cube root of negative 64? Can you look at your pink paper and look at the cubes? Okay, this is how you use the pink paper now. Cube root of negative 64, you look at what number was it cubed that gave you 64? 4, but it's negative, so it's negative 4. The next question says, what is the 5th root of 32? So go look at your powers of 5. Okay, go look at that spot on the pink paper that says it's 2 because 2 to the 5th is 32. Okay? Case 2, if n is even, so let's circle that. If n is even and a is positive, then there are 2 real roots. And let me explain this one. So it says, what are the 4th roots of 81? 3 and negative 3. Because if I take negative 3 to the 4th power, a negative 4 times is still positive 81. If n is even and a is negative, there's no real roots. So in example 7, if I said to you, what are the square roots of negative 81? There's no real root because negative 9 times negative 9 is positive 81. All right, so we're going to use this to do the next group. And I hear you flipping already, so that's fantastic. And please, feel free at any time, if I'm going too quickly for you, just politely say, would you please slow down? Because I'm happy to do that. So I'm going to pause, and I want you guys to try example 8, 9, and 10. Do as much of it as you can. using the pink paper. Just to make sure you're getting off to the right track. If I want the square roots, that's an even root. It's 12 and negative 12. But cube roots, there's only one, okay? Because 3 times 3 times 3 is 27. Odd roots have one answer. Even roots have 2 as long as the radicand, what's underneath, is positive. So just to make sure you're getting off on the right track. Now try the rest of them if you weren't done. And I do strongly recommend, if you struggled last semester at all, if you were not re-watching the videos, because I'll record this either this period or 7th period, watch the video again. It's super, super helpful. All right, so in example 8, letter B, plus or minus 8. Letter C, not a real root, because I can't take negative 4 times negative 4. When you're talking about roots, it's one number times itself that many times. So a square root is times itself, a cube root is times itself 3 times. So letter B, negative 2, and letter C is 5. There's only one answer. The fourth roots, plus or minus 2, plus or minus 3, not a real root. What questions can I answer for you? All right, here's a little exploration. Simplify what's underneath the radical, and then, now I need to say something here, okay? If you see a radical symbol, there's not 2 answers that come out of it. But when it's written in words, it can have 2 answers. So on this one, letter A, this is going to be the square root of 16, and then the square root symbol tells you whether it's positive or negative out front. So in this one, you're not going to be putting plus and minuses. But in words, because it just says, what are square roots of 144, I don't have the symbol, it's either 12 or negative 12. But here it's telling me it wants the positive roots. So this is the square root of 36, which is 6. This would be the square root of, do you understand? Negative 7 squared is positive 49. So even though letter C had a negative underneath, it was being squared, so it took care of my negative. So, does anybody want to try the generalization? This one's kind of tricky.
You just cancel.
Okay, you're on the right track. It is canceling, but my answer here wasn't negative 7. Yeah. Yeah, nice job. It's actually got to be the absolute value. It's got to be the absolute value because what's going to spit out is positive. And what we learned back in chapter 2 was that absolute value. So my next exploration says, what if we change the index? And the word index is another word for root. So if I do this, you can use a calculator if you have one. Negative 4 in a parenthesis cubed is negative 64. Use your pink paper then. And what's the cube root of negative 64? Negative 4, right? It's actually a negative 4, because a cube, I can have a negative underneath. Square roots, I cannot. All right, letter B. This would be the fourth root of positive 16. Oh, that's not negative 2, it's positive 2, isn't it? because negative 2 to the 4th is positive 16. All right, then letter C. This becomes the 4th root of positive 81, which is 3. So if I take this up to, instead of just a square root, if I change it to any other index, guess what? The nth root of a to the n is the absolute value of a. All right, now using this, try example 11. I'll give you a head start. And it is possible on this one to get not a real root, and you can abbreviate it NRR. When you're ready, check it at the board. Letter A is negative 3. B is not a real root because I have an even and it's simplified with a negative underneath. Letter C is possible because negative 7 squared is positive 49, so that's 7. Letter D is not a real root. All right, what questions do you have? Anything? Yeah.
Letter D on this is just 49. It's
Yeah,
not
it's
negative.
positive.
Oh, is it? Did I change it on yours? Oh, okay, thanks. So if that's a positive, then what would it be? Yeah, nice. I'm glad you asked. For some reason, mine was different. Okay. All right, when you're ready, flip the page. Okay. So this next one, once you get the hang of this, this is like really straightforward. What do you do if we put letters under the radical? And I'm going to do several of these, and then I want to see if you can tell what the pattern is. So look at letter A. I have the square root of 16x to the 8th. Well, I know the square root of 16 is 4, and it's x to the 4th. And the next one, this is going to be 6x to the 7th. And this one's going to be 3x squared y cubed. So go ahead and jot them down, and then I'd like to see if somebody could generalize this for our class. What do you think? The numbers are the numbers, okay? You know what square roots are. But can anybody tell what did I actually do to get the exponents on the letters? Yeah, Mia, what do you think?
They were like divided by 2.
Perfect. That is exactly it, okay? They are divided by 2 because it's a square root. Now watch this. Letter D is a cube root. I'm going to blow your minds here. The answer for letter D would be AB squared. What did I divide by?
3.
The 3. All right, does somebody want to try letter E? Somebody feeling really confident that it's a cube root of 8? Chris, what do you think?
Cube root of 8. I know the variables would be 3 and 5. For the 8 though.
Look at your pink paper. Look at the cube paper.
2.
Yeah, bingo. You got it. So that's 2x cubed y to the 5th. All right, you guys try F through I. Do as many of them as you can. All right, Jacob, what did you get for letter F?
3ab cubed c4.
Good job. You got it. Okay. All right, Brooke, what did you get for letter G?
XY squared.
Nice. XY squared. All right, Jesse, what did you say for letter H?
2a cubed e 5.
Nice. Okay. All right, Cameron, what do you say about letter I, the last one?
Is it a squared b to the fourth?
You got it. All right, thumbs up, out, or down? How do we feel? Thumbs up, out, or down? Let me see all thumbs. George, what do you got? Theron? All right, cool. Okay, so why would you, who cares? Who cares about radicals? It's funny, on Facebook I had a friend say, yeah, I'm so glad I learned about parallelograms instead of learning how to do my taxes because it's parallelogram season. Being sarcastic, but so we do want to know who cares? Who cares about radicals? So here's a situation. Some teachers adjust test scores when a test is difficult. You might have had a teacher, it's not very common in high school, but in college it's quite common for a college professor to curve. Okay, but you may have had a couple of times where a teacher in high school might curve. I rarely do that. I don't give you a test or a quiz unless I think you're ready for it. But sometimes it can go haywire and a teacher does need to curve it for some reason. So here's a formula that one teacher used. A equals 10 square root R. A is going to be this new adjusted score. R is called the raw score, and that's the original, okay, what we call the raw score. If the raw scores on one test range from 36 to 90, what is the range of adjusted scores? Any suggestions? What might we do to find the new adjusted scores, that range? So the raw scores were 36 up to 90. And I want to know what the adjusted scores would be from the bottom to the top. Jesse, you got any ideas? No? Julia, how about you? What might we do?
90 minus 36.
Nope, I don't need to subtract. You plug it in, right? Okay. All you're going to do is plug in. The low score was 36. So 10 times 6. So my new adjusted score, the low score is a 60. And then if I plug in, ooh, that didn't work out very nice, did it? So if you have a calculator, this one didn't work out so nice. Square root 90 isn't on the pink paper. It's not a perfect square. So if it's not, you do use a calculator. So does anybody have their calculator? Take the square root of 90, which is some decimal number, times 10. I got 94.87, or we could say, now my scores are going to be 36 to 90 will be 60 to 95. All right, let's flip the page and wrap it up here. Here's another cool area. If you are interested in becoming a police detective, if you're interested in forensic science, radicals are actually used. And that's kind of the sad thing is we try to bring in the word problems, but until you get into like your real job, you'll go, that's why we learned that in Algebra 2. You actually will see weather, if you're interested in weather, hurricanes use square roots in them. So there really are some neat areas, and I realize, you may not be going into any of those three fields I just mentioned, but they are used. So, and that's not limited to those three, there are other areas. But here's another problem. It says the speed S in meters per second of a car leaving a skid mark d meters long after the brakes are applied is given by this formula. S is the speed equals the square root of 15d. So I want you to think here a moment. When there's an accident, sometimes people lie about how fast they were going. Sometimes there's a fatality or an injury where the person is not able to speak about what happened. And so a detective can take the physical evidence that's there. They can measure that skid mark length, and they can figure out how fast the car was going to determine, was the car speeding? You know, is there a fault on the driver's part? It says, if you measure a skid mark is 180 meters long, how fast was the car going? Again, if you have a calculator, you can take the square root of 15 times 180, and I rounded and said 52 meters per second. In the United States, we don't use meters per second, we use miles per hour. So this is kind of a weird measurement for us. All right, in example 13, it says find two real solutions. Now this is an equation. So we saw words, we saw a radical symbol, and now we're seeing an equation. If I have x squared equals 79, x would be plus or minus 7. And we did this back in chapter 4 in our quadratic unit. Letter B. If x to the 4th is 16, you can use the pink paper or you can use a calculator. This is plus or minus 2 because 2 to the 4th is 16 and negative 2 to the 4th is 16. Now use your pink paper for example 14. If I have x cubed is 216, what would x be? 6. And in letter B, if I have x cubed is negative 64, what's x? Negative 4. Now it says compare these two. And even power has two solutions. And odd power has one solution.